Super excited that Matt Hansen was able to make the way up from DC. Just moved to University of Maryland last year or this year, actually, yeah, from South Dakota. He's really a globally recognized leader in land cover modeling, among other things, but that's what he's really famous for. And we've heard from Woody already how remote sensing really, in a way, equalizes the globe all the way from the tropics to the high latitudes. I think we all can believe in this global vision that's partly facilitated through remote sensing data that is so global and so high quality. And Matt is one of the leading thinkers in global land cover modeling. So thank you, Matt.
Thank you very much, Walt, for including me in this symposium. I'm sorry I missed yesterday. I would have enjoyed very much learning because I am a bit removed from this community. I'm going to be talking about our land cover and change mapping capabilities and how we're getting down to a granularity at a global scale where we think that the data are going to have be very useful to modeling aspirations in the biodiversity community. And we do work with conservation groups. A lot of this work was derived from projects in Central Africa based on, with the focus on conservation mapping of last intact forest landscapes and that sort of thing. So a lot of it has to do with biodiversity conservation, and we've scaled it globally. That's another track, is trying to make globally consistent products that have local relevance, and you'll see if we're making progress there as I go through the talk. I'd like to acknowledge Peter Potapov, who's really implementing, advancing a lot of the products you're going to see in this talk. And it is a consortium of different groups. We have Google Earth doing a lot of processing for us in parallel with our capabilities. And I'd like to highlight, obviously, NASA. All of this results, all of the vision for emphasizing global scale monitoring of the land comes from NASA programs, and all these results are the result of NASA support. Real quickly, in 1994, colleagues of mine and my former committee, actually, John Townsend and Ruth DeFries at the University of Maryland, made a 1 degree by 1 degree land cover map. It was 360 by 180 pixels in 1994, and they got that published in the International Journal of Remote Sensing. That was a big deal. And you can imagine how small that file is and how blocky and unsatisfying that kind of depiction is. But that's where we were in the mid-90s. And so that's that square, this biggest square. And then we advanced with a meteorological satellite, AVHR, and we were working at 8 kilometer and 1 kilometer by the close of the millennium. And then MODIS went up. MODIS is a land monitor. It has land bands anyway, 500, 250 meters. So through the first decade of this century, we were going down to 500 meters, 250 meters, getting into looking at change more clearly because you get more discrete, finer scale resolution. You can start mapping change. And then as Woody alluded, they opened up the Landsat archive 3 years ago. And now our aspiration, and we've got some prototypes, but we're just working on this idea of mapping repeatedly the globe at 30 meters. Idea, again, of having a global algorithm that gives you a global synthesis is very nice, but when you cut out any particular area, it has local relevance. That's our goal. And of course, when you're working at a park boundary or you're working inside an intact forest, having these type of disturbance data, and you can compare them across countries and parks and that sort of thing is very important. But anyway, where are we going to be in 10, 15 years? That's what I like to think about, and could be a problem, but it'd be cool to be working at like sub 5 meter globally in a little bit. So I'm just going to show you a little background with MODIS. MODIS, we practice our algorithms with the data that were available in the 90s and 2000s. So AVHR and MODIS, daily observations of the land surface. How do you process these so that you get through the clouds? We're working in the optical domain, so we're not working with radar. How do you get through the clouds, see the land surface, characterize it, and see how it changes through time? So this is a single day's acquisition of, it's a polar orbiting satellite. The orbits come apart at the equator, so you have these gaps. They overlap at the poles. Take these data and make cloud-free imagery that we call metrics, so you try and selectively pick the right observations that allow you to see the vegetation cover of the surface, and then turn that into characterizations. And this is an example of a forest cover loss product for 5 years, so that you take those time series of observations, calibrate it with some finer scale data, and then come up with a quantification of a dynamic at a global scale. This is very coarse, but it's a result that we characterize the uncertainty about. And why is this valuable, even at this coarse scale? Well, to date, our global environmental data come from groups like FAO. They have the mandate to do global environmental, whether it's forestry or agricultural statistics. And you look at the globe, you see North America very quiet. There's no change going on there, and that's because they use a land use criterion in the forest domain. And whether there are trees there or not, it's still a forest from a forestry perspective. So they don't call a lot of the dynamics occurring in North America change. The point being that FAO, because countries submit their own statistics and there is not a consistent definition, what you call a tree in Namibia is not what you call a tree in Congo, it's hard to get a global story. And the FAO data are roundly, and I feel kind of sorry for the FAO because they have to deal with this inconsistency and try to come up with a synthesis. But when we look at the satellite in terms of disturbance, we see that places like Canada have as much disturbance as Brazil. The USA, in terms of proportion of disturbance given a reference forest area, is the highest disturbance level for countries with over 1 million square kilometers of forest. So the satellite allows us to do apples-to-apples quantitative comparisons. So what we've done is we've moved on to Landsat, and we've tested this product, tested our methods moving down to 30 meters at a whole host of different biomes, European, Russia, to Mexico, to Indonesia. And I'm going to go through some of those examples right now. But the key thing, this is why, for a lot of biodiversity applications, we're at a fairly coarse scale even at 30 meters. But we have a certain set of criteria if we're going to do global monitoring. We actually have to have data globally. So you have to have systematic acquisitions. And MODIS and Landsat are systematically being acquired. A lot of European sensors, they're commercial. You task them by project. The Brazilian sensors are not, there's not a global receiving network right now for them. So NASA instruments and USGS in terms of Landsat afford us this capability. Like Woody said, they're available now at no low cost, these 30-meter data, so we can access the archive and mine the entire archive. We used to write a paper just on one image. Now we can stack up 10,000, 100,000, 500,000 images. I'll show a test of using over 500,000 images in a little bit. Easy access and pre-processing already done. So there's a certain set of criteria that allows us to do global monitoring. I'm going to show just some of the issues related to, this digital image processing, you have to have some expertise in it. This stuff is not off the shelf. So we do use a set of corrections. We evaluate every pixel to try and assess its quality. It's a big, long chain of processes, not germane to this, but just to make sure that, we have to automate these procedures, evaluate them, and test them. So this is a MODIS cloud-free image. This is the kind of data that we use to integrate. Integration for me is not the kind that what he's talking about. It's like MODIS and Landsat and other satellite data sets. We try to integrate different observations to create a way to process data automatically. So this is an old slide, but it kind of captures the idea. You might get raw data that looks like this over the Congo Basin. How do you map the Congo Basin consistently so that the change you map in the southeast corner of Katanga province is the same that you get up in Equateur province in the DRC? And we have a set of corrections that are, kind of hard. They are hardwired, where we go through and we get rid of, we try and create a top of canopy look, correct for anisotropy or bidirectional reflectance distribution function effects, composite temporally. And so pretty soon, you get this picture like, I can map that and I can monitor at that scale. So it's all about the technical kind of automation of the pre-processing. And then our goal is, this is what we would have with MODIS at 250 meter. We can get our 30-meter data looking the same way. I can apply my algorithms that we were using globally with MODIS to data such as Landsat. So that's the idea from a kind of technical standpoint. We also need to do QA. This is very important. I want to show you some examples conceptually why it's a challenge to map the globe, and it has to do with clouds basically in our domain. But Brazil and Australia are the state of the art in terms of forest monitoring. Most of my examples are forest for this talk. And Brazil has this seasonal dry season that gives you a cloud-free window, July-August timeframe, and they take each year they get a clean image, and they compare that to last year's image, and they map the bulk of the arc of deforestation where the big dynamics are occurring. Australia, the same way. The real cloudy part in Australia is Tasmania. That's where the radar people make a living, right? They work in Tasmania. And it's all based on single-date imagery because they can count on it. When you go to higher latitudes and look at the arc of deforestation about 12 degrees south, this is Mato Grosso, this is the equator. You go into the Congo, you go to Indonesia, you got problems in terms of getting cloud-free data. So that's what the arc of deforestation looks like in southern Brazil, Mato Grosso state. Here's Indonesia. So to show you our problem, this is why data policy is a big deal and why having an open archive is a big deal. Because when we look at a single path row, this is the observational kind of element of the Landsat sensor. This is a year's worth of data for an area in East Kalimantan on the island of Borneo in Indonesia. So you might want to start out saving the orangutan and become an atmospheric chemist or something, right? It's really hard to see this. So there's no cloud-free data, and the idea is how do we, but there are literally millions of good observations in these data, and we have to filter them and find them, and we can make this kind of product, where we see through the clouds by stacking up good observations, evaluating them, and mapping the change in red on terms of the forest disturbance over a 5-year period. So again, high volume data processing with taking advantage of an open data policy. And then we go through our characterization validation. We map and document change. So in Indonesia, this is an example of we've done 10 years now. I think this is an 8-year product where we're mapping, and you see this west to east disturbance where Sumatra is in a kind of cleanup operation of all the lowland forest. Kalimantan is on its way. By the time you get out to Papua New Guinea, it's just inroads, just selective logging roads going up into the interior of the island. And we map the change in an aggregate sense, and then we disaggregate it annually. Now here's what's cool about having 30-meter data globally. We're going to map all these disturbances, and we're going to know the ages of these forests. We're going to keep a record of all the disturbance history of each of these parcels. So imagine that. You have a 30-meter record, and we can push this back a little bit. It's more about moving forward that we're going to have these data in a more practical sense, being able to do it. But kind of a land use history or disturbance history per parcel of land. This place right here was cleared twice in 10 years, and we see that, and we map it and record that. And the value is when you put it over, let's say, land use zoning polygons. And so there's a couple zoning polygons in Indonesia that are where forest loss or logging and clearing is illegal. But when we map our change on top of these two island groups, Sumatra and Kalimantan, we get almost 10% occurring in these land uses. Limited production forests are also where it's supposed to be selective logging, but clearing happens and has been increasing. So here's limited production forest. Here's these conservation forests contributing a considerable amount of disturbance to the total for the country. And this for biodiversity is obviously a big deal because the protection forests are the national parks. We also put the change in context of references in terms of intactness. So we have a method for getting a frame of reference when we start the monitoring to say that a certain portion of Sumatra is intact. In other words, it has no evidence of human infrastructure, no roads, no settlements. And so this is a high biodiversity, high carbon target. And so we go through a process to map that, and that would be these dark green forests that have not had recent historical change, and we map how those are lost over time. And then these become targets for future monitoring. If you see a logging road going into these polygons, that's a bigger deal from a biodiversity and or carbon perspective. So this kind of product pantropically is something that we're working on now as well. The other cool, really neat thing about these data is that when you map an algorithm at a continental or global scale, you get real boundaries along administrative units. So you see governance, you see markets at play across different units. So when we go into the center of Borneo, we see that Malaysia very aggressive in terms of clearing right up to the boundary with Indonesia, even though Indonesia is the one you always hear about because they're a developing country, part of the RED mechanism, a lot of investment there. Malaysia doesn't have that, and their kind of management of their forest very different, much more aggressive in terms of exploiting the timber. Democratic Republic of the Congo, totally different story. You have a war, about 3 to 5 million people dead in 15 years. Not a lot of data, but there are. We work with conservation groups working in priority landscapes across the Congo Basin, mapping the change inside and outside of those landscapes, working with conservationists to assess biodiversity richness. Like John Hart of the Wildlife Conservation Society uses our data to go target biodiversity transects, finding new species of bat, like in the Atombwe Massif and different things. So it's a nice collaboration with the big NGOs. And then looking at changes inside and outside of parks. And if you see a place like this where these dark colors are high rates of change, here's a park near the Kinshasa, the capital, where there's greater change inside the park than a buffer around the park. So these are like hollowed out parks that are not retaining any kind of the forest structure in terms of conserving, and keeping disturbance outside of it. Here's a Virunga National Park, a big tragedy there with a lot of displaced persons and charcoal being cut and agriculture encroaching inside Virunga National Parks. You see a front of disturbance violating the integrity of the park. So these type of data obviously are bringing meaning again in a kind of regional context across the Congo Basin. We also do it in other regions. Again, we're working towards a generic implementation. So this is the United States with Landsat data. This is called the WELD data set, being produced at South Dakota State University, and producing forest cover and a series of different cover dynamics. And so here's an example of forest cover loss for the United States over a 4-year period. And I just want to show this example here real quickly. This is a measure of what we would call core forest, or something related to recent intactness. So if we take all the forests and we kind of penalize areas that are forests that are in proximity to change, we see this huge, basically the forests of the southeast, and most people know this, it's basically trees are a cropland there. And there's no real extent of forest that is absent of change. When you get in the mid-Atlantic, up into New England, we have these forests that have been intact for a long time. The best ecoregion in terms of lack of change and kind of forest extent is in the Adirondacks here. We have some other ones up in the Northwest. So this idea at a global scale, we can map these forests that are not changing and that are changing, and then try to say something about habitat integrity potential. And so we've labeled the kind of high core forest ecoregions, the median, and then the low, and all these low ones that have a lot of forest, but it's continually cycling in and out. Very different structure, very different floristic compositions, because it's a commercial endeavor, are all in the southeast U.S. To highlight that we do stuff beyond forestry, this is bare ground, and it really is it's a different kind of product, but the idea is to map where vegetation is lost permanently to a bare ground, to a kind of a development conversion. This could be mining, could be an airport extension, could be a road. And the interesting thing about these kind of products is they're just cool. I mean, they talk about the airports being the future downtown, the CBD of the future. If Denver builds their airport 30 miles outside of the city, it's not a big deal. The city will grow to it, because that is the way you connect to the world. And a lot of these initial products in terms of the United States and bare ground change is reflecting that airports are kind of like this center of conversion. But again, doing this globally, seeing all the urbanization occurring in China, all of the developing world megacities growing, this is the type of data that will help us map that footprint. Okay, we've tested this algorithm globally, and we're working towards a global implementation. And it's early days, but we have some very kind of convincing results. And I'll tell you, when you pan around a product, you see that there's very few landscapes we don't mess with. It's incredible. I mean, if you talk about Scandinavia, Canada, you name it, I think maybe Venezuela might be one place where there's not a lot of changes. It's pervasive everywhere. So I'm going to take a virtual transect from Canada to the U.S. to Central America, Brazil, and then Argentina and Chile. And what we see, and this is a global run, just a test global run, but here's red is loss in this area of Canada and Quebec. Blue is gain. So we're doing both the net, the loss and the gain to get net. And a lot of times in the high latitudes when they log it, it doesn't come back for 70 to 100 years, so we don't see a strong regrowth signal here in 10 years. This is a 10-year result. Here's Alabama, plus and minus. So look at that pervasive. I mean, what does that mean for biodiversity, that rate of change in 10 years? 80 kilometer by 60 kilometer. The whole southeast is like that. And if you've driven through the southeast, just some backcountry road, you see the forest. They're used. I'll just put it that way. Here's an example from Central America where we have Belize, and you can see the border of Guatemala here coming out. So you see these transnational boundary effects everywhere. You see certain levels of kind of scale of change that might be smallholder versus industrial. Interesting dynamics to kind of quantify. This is a nice example because it's one of the places that we haven't seen cloud-free. So this is the western coast of Colombia. I just include that in there because if you're a remote sensing geek, you're really excited to see a place that you can't see typically. Agroforestry in southern Brazil, place where it's not a forest environment, but they've introduced eucalyptus and other species for forestry. This is true deforestation in the Chaco. There are places in the last 10 years, and Chaco is one of them, where the rates of change are we haven't quantified this data yet. We're still validating it, but the rates of change are unprecedented, and it's deforestation of entire ecosystem from Bolivia through Paraguay down to Argentina, all to do 10 kilometer by 5 kilometer soybean fields to sell soybeans to China. In Cambodia, we see rates of change that we haven't quantified, but double-digit clearing inside national parks. So it's this big alarm going off, I would say. The story is quite scary. And then Chile, just incredible agroforestry. So we have this crazy dynamic land surface in the forest, much less agriculture. This is an example. We had Jane Goodall come by a week ago, and we just panned around our product and looked at some different ideas. Just the way these data reflect certain dynamics and the forest cover in the context of a new initiative theirs to do a habitat health assessment. So they whether they're chimpanzees there or not, they want to identify these parcels of forest that have potential for being good habitat, see how they're connected to other parcels in terms of corridors. And we just panned around and looked at a few examples. And I'm going to show you what those look like right now. So we zoom into the southwestern corner of Côte d'Ivoire. This is Thai National Park. So if you saw the Disney movie, Chimpanzee, this is where those chimpanzees were. And our change alarm, our change product for the last 10 years is in red here. So you can see it kind of envelops the park. Here is a park that is hollowed out. So not only do you see transnational effects in terms of rates of change, you see it within countries where the governance or the protection of this area doesn't exist. And Thai National Park really looking good. And we go down to the next, then we look at the imagery. There's the Thai forest all intact, and that's good news that it has integrity. Lillian Pineta of Jane Goodall said that's fine, but when disease hits this, there's not going to be a way to escape it. There could be a big, just obliteration of the chimp population. Here's Liberia, good potential habitat, but no real status, and there's some concern that these forests are going to be logged soon. There was something new. So anyway, this nice story about the differential rates of impact and governance and how that affects habitat for chimps. We're going to zoom down here to the coast of Central Africa. This is a cool example because this is an exclave of Angola. It's called Cabinda. And there's no change in there. It's really kind of an outlier from the rest of the country. This hasn't seen a lot of development. This is the lower Congo that has a lot of population pressure. And even though this is a reserve, the forests have all been degraded there. And so the Jane Goodall folks want to think about adding this area to a corridor going north through the lesser populated Republic of Congo and Gabon. And if I go back and forth, you can see that boundary coming out. So Cabinda is a good site, and they know that there are chimpanzees in these forests. And so here's the border, and Congo is right out of the loop as a potential harbor of chimpanzees. One last example, and this is bonobo country, not chimpanzee country, the pygmy chimpanzee. Here's an example of a place that changed 30 years ago. It's this big void, and you can see the change around it and along these trunk roads. But in here, you're going to see, when I click on the next slide, this was logged 30 years ago. And there's a lot of places that were logged in Central Africa, and they left, and biodiversity returned to these sites. And they found a good site in the Republic of Congo where they found large numbers of primates inside a previous log forest. So this idea of time series, not all change is the same. If we can withstand some logging and not have populations move in and kind of progressively appropriate the forest for different land uses, this could be good habitat. So just another different idea. Okay, so in conclusion, we're really psyched, really happy that we're working at this medium resolution now, 30 meters. We're going to be doing global land cover change. The scale of change is hard to comprehend, really, and we're going to have to develop models that accept these data almost in near real time. And that's our goal. Our goal is to the latest image comes down, and we send out a product that says this place changed. And whether it's a land manager or a modeler, hopefully can incorporate that data either to improve the model or to make a decision in terms of how to better manage the resource. Data policy is critical to this kind of a method. The idea of the commercial domain being less or equal to 5 meters, and that's where it is. We're not going to do global monitoring that way. It costs too much money, and if that scale is needed for certain applications, the only way I can conceive of it is maybe with a targeted sample-based approach, because it's just a huge land surface, and the costs they're hard to imagine. And so data policy moving forward beyond 30 meters is a big deal. We have to validate our products, obviously. We have to attribute the change. All of our disturbances are not the same. You have fire, you have disease, you have logging. I mentioned this idea of all changes are not equal, so we're very concerned, at least from our partners in the conservation world, in terms of primary intact loss. We're working in other cover dynamics. And then we also work with developing countries because we want to give them ownership over the process and have them advance their capabilities for monitoring their own countries, not have us feed them the results, and that doesn't work at all. They don't accept it, and rightly so. They want to be in command of their, and we're going down to Peru this week to do an exercise and map 10 years of change in Peru. And we've already got a product, but in a week we'll have mapped 10 years of the country, and they will have driven the process. Then to think about where we'll be in 10 more years. If we do move down to this scale, are we going to overcome some of these data policies so that we can move from 30 meters down to 5 meters globally? I think that's really exciting, but I don't know if it's a realistic expectation. Thank you.
Thanks so much, Matt. Super fascinating. So I hope you sort of would agree with me that this sort of technology, this sort of research can be a real game changer for biodiversity modeling. And that was my big motivation for persuading Matt to come up here. I think we can learn a lot here, and you see where this can be in 5 years from now through efforts like that. So questions? Here. Oh, yeah.
Thank you for your talk. You touched briefly on validation. I'm just wondering, how are you going about doing accuracy assessment for all the change products that you're producing, particularly when you're looking back in time in a lot of cases?
Great question. You can help me with that. Now, when you look backwards in time, you typically, the validation, you would like it to be derived from a finer, a better reference. And so if I'm doing a 30-meter map, I would love to have a 5-meter reference or something that would give me a better sense of what I'm omitting in terms of scale and all that kind of stuff. There is no systematic record at that scale, so it's hit and miss where those data sets are. In the U.S., when we look at like the last 10 years, even on Google Earth, there's great records. There's agencies like the Farm Service Agency, I think that's the one, that does regular aerial overpasses, but globally, there are huge voids. So we have to do like with like if we go backwards. It's usually handcrafted Landsat where an analyst works on something very detailed using ancillary information saying this is what happened. Sam is working on that, and he can share how difficult that is, the gentleman in front of you. But moving forward, I do like the 5-meter or less targeted samples, and we will nail that. We will be very good at understanding our accuracy of these algorithms prospectively. Historically, we have to use the data that are there, and it's not going to be statistically perfect.
Ron, you had a question?
Yeah, so many questions, so few time, but...
Ron is the head of our Center of Earth Observations here.
You've alluded to some new tools for doing cloud removal with Landsat that I'd like to learn about, but I guess my question now is, we're into a Landsat gap, and I wonder what's going to happen to this Landsat time series from now on forward.
Okay, all of those products are Landsat 7, scan line corrector off, so we use those data, and the gaps are like a cloud to us, so it's just bad data. It means we have less observations there. And in a place that's really cloud impacted like the Guinea coast of Africa, we see problems. So we don't consider it a gap right yet. We're using those data. And then Landsat 8 is supposed to launch February 12th, and that'll be huge. But that's where we hold our fingers crossed. It's 8 days separate from Landsat 7, so we'll be able to use those in concert. So maybe a year from now we're rolling in data and we're doing well. But it's all about that launch, if that works. So we're doing pretty well with a broken instrument. And when we add Landsat 8 to it, it's going to be stellar. We're excited about it. Yeah.
So this is just fascinating how much information you can actually get out. And I noticed as you went and panned around your globe, it seemed like there were different economic, sociological drivers in all these different places influencing the deforestation. So I wonder the extent to which you're working maybe with social scientists or others, and is it ever really possible to sort of come up with some sort of predictive idea of what's going to happen?
It's funny. I think so. I think when I look at it, I see economics, socioeconomics. That's what I see in governance. And places like Africa, the forest structure is intact because it's so poorly governed. And Mozambique and Angola stick out of the satellite because they were at war for 25 years and nobody really exploited their forest. Mozambique has a transition to democracy, then all of a sudden the global market's in there, and all of a sudden it starts changing rapidly. Places that are wired to the global market, insular Southeast Asia, Malaysia, Indonesia, Argentina, huge changes. I mean, they're appropriating the land, and they're doing what we did, I guess, a century ago. So I think that's a huge, econometric, whatever you want to say. It's not my expertise, but hopefully, our idea is to get these data out, and people can make those kind of analyses. But that's what you see. I can't really build on it more than that. It's really interesting.
So how can we access your products?
Yeah.
Are you going to make the copy available?
Right. We're in the process of validating the global product. Some of our products are online, our European Russia product, our Congo product. So but they're kind of just hit and miss. The global product, I would imagine in the next 3 to 6 months, we're going to have that out, and hopefully as well imagery, so that people can play with their own algorithms to see what they can make of it as well. And that's another thing I'll mention that we're getting rid of in the coming years. USGS has an initiative. The data are called WELD, where we're not going to be using path row anymore with Landsat. You're going to get Modus-type tiles, and you're going to be able to do your own algorithms and not have to worry about all this hand-holding of processing. So that's a big deal. I think 5 years from now, it'll be more democratic in terms of how many people can use these data with not a steep learning curve.
Karen?
Yeah, thanks, Matt. That was really interesting. I think the remote sensing community still largely thinks about accuracy in terms of a particular time, just one date and time, the classic change detection type. And I think we're getting at a point now with the entire Landsat archive and other data sets that we're now really starting to think about temporal accuracy. But the community doesn't think about it that way, and certainly the user community doesn't think about it that way. The user community is thinking about 2 points in time, and so some of the maps that you showed about change, and that's like 2 points, or maybe it's 3 points, but I think that there's a big disconnect between some of the algorithm development in terms of using the entire time series to look at change over an entire time period, and how we really conceptualize change. And then also, I think there's another issue around how do we start thinking about and applying phonology across different biomes in terms of thinking about training data, and I think the question earlier about accuracy assessment. So can you talk a little bit about how these are incorporated in some of your thinking right now and folks at UNB?
Right. That's a great question. We do take this approach where, we're more interested in the change actually than just a static land cover map. And so, I can take a decade's worth of observations, stack them up, and look for the change inside that record, and then backtrack, retrospectively backtrack when the change occurred. So, like in Indonesia, there's a place that's forest. It is cleared in 2000, cleared in 2002, grows back in 2006, cleared in 2009. You have that kind of dynamic in a very cloudy place. So it's really strange. You will never get a single year composite image that's clean in Indonesia. So it's a really difficult thing, and so the only way we really thought to do it was to stack everything together and try and go directly for change. I think validation for change is similar to doing a static map. The statistics behind it and everything are. The challenge with change is if you do it over too fine a time step, change is such a small fraction of the land surface that your errors, if you're wrong at all, you blow up your estimate. So in other words, like in the Congo Basin, if it's a 0.5% change, I could easily double that with my algorithm, and then you have a 100% error regarding change. So change is a difficult thing to validate. Over 10 years, the amount of change we're seeing, I think we can have uncertainty bounds around our estimate that don't make our map look like garbage. But yeah, we're doing the same methods of validation, but just for a change class, and that class is forest loss, it could be forest gain, whatever. What was your second point? I thought that was a good question too.
So the change is really about 2 time periods.
It's bracketed. It happened inside that period. It's not a time 1, time 2 thing. It happened sometime in between. That's the way we think of it. Because if you took a time 1 image and time 2 image, you'll miss a lot of change in between. You will in some of the tropical areas. But you had a second point that I liked. What was that?
All right.
Oh, phonology, yeah. So with Modus, we can in effect ignore phonology. We bin our data on temperature, on greenness, all these different kind of rule sets, And we can create a global image that looks clean without regards to time of year or phonology. It's really quite neat. Landsat, not so clean. This first test, we've used MODIS to define growing season, and we've focused on growing season. Off-season is really valuable in a lot of places, but the acquisition of Landsat is really, even though it's a global strategy, it's inconsistent place to place, and it's hard to ignore phonology like we do with MODIS. We really ignore it with MODIS. And in Landsat, we have to pay, we have to look for a sweet spot that's consistent globally, and it's a little harder. I don't know if but I can explain it a little bit more, but phonology should not impact our change results is the point. We work very hard to make sure that doesn't happen.
Great. Well, unless there are any super critical, urgent questions to either Matt or any of the previous speakers, if there's anything on your mind, we can perhaps bring it up again in the afternoon session. Have a little general discussion at the end.